Lesson 3.2, Task 4. All right, so we're still using slope to find slope of line and rate of change. And now we're going to look at the slope to find another point on a line. If you know the slope of a line and one point on it, you can find another point on the line. A line with slope 3/5 passes through -1, -1. Determine another point on the line. Begin by plotting the given point. Then use the given slope to find another point on the line. The slope indicates the rise is 3 and the run is 5. So here's the given point, -1, -1. So from the origin, you come over -1 and down -1 and plot that point. From there, you can use your rise and your run to find another point. So if you rise 1, 2, 3, and you run 1, 2, 3, 4, 5, this gives you another point on that line. So 4 is your X, 2 is your Y. So 4, 2 is another ordered pair on that line. All right, so it says moving 3 units up from -1, -1 takes you to -1, 2. So you see if you go from -1, -1 up 3, that takes you to -1, 2. And then it says move 5 units to the right from this point, and it takes you to 4, 2. The point 4, 2 is a point on the line. All right, so it says match the types of rise and run with the corresponding directions. All right, so positive rise, positive run. We know rise is your Y values, so it's going to be up or down. Positive means you're going to go up. And a positive run, so your run is going to go left or right because that's your horizontal movement. A positive run is going to take you to the right of where you are, and a negative rise is going to take you down because rising is up or down, and then a negative run is going to move you backwards or to the left. So that basically determines the sign on the number. All right, so it says, how can the slope formula be used to verify that 4, 2 is indeed on the line? Complete the sentence. Substitute 4, 2 and -1, -1 into the slope formula. You will obtain a rise of, so we can do 2 minus -1. So they're doing y minus y, so 2 minus the -1 here, so 2 minus -1 would be 2 plus 1, or 3. And then a run, 4, so your x's, difference of x's, minus -1 would be 4 plus 1, or 5. This yields a slope of 3/5. This shows that the line through these 2 points has the correct slope. So if you go back up here, remember it says that the slope is 3, a rise of 3 and a run of 5. So the line with a slope of 3/5, and since we just used those 2 points to check that, we can determine that 4, 2 is a point on that line. All right, that's all for task 4. If you have any questions, let me know. Lesson 3.2, task 5. Find an average rate of change. Linear relationships involve a constant rate of change. That rate of change is the slope of a line that models the relationship. Some real-world situations involve more than one rate of change. In these situations, an average rate of change can be determined. All right, so for Tracy here, the jogging time is 10 minutes and the running time is 40 minutes. So he runs at 2 different rates. So we're going to look at his average rate of change. So Tracy runs every Saturday to stay healthy. After stretching, he always begins by jogging at a steady pace. He uses a fitness watch to monitor both his time running and his pace. At the end of his jog, he immediately increases his pace to his regular running speed for the remainder of his workout. Find the average rate of change, average speed, for his entire workout. All right, so this is the graph models his time and distance run during his workout. All right, so you can see his first 10 minutes is more gradual, so it's kind of slower because he's warming up. And then when he starts his workout, the next 40 minutes is faster. So from 0 to 50 That's his entire 50 minutes of activity. So this is time in minutes, and this is distance per mile. All right, so it says determine the rate of change for the 10 minutes while he is jogging. So you've got 0, 0 as a point, and you've got 10, and if this is 1, this would be 0.5. So you can use those 2 points as your y2 minus y1 over x2 minus x1 to find your slope. When you do that, you get 1 over 20. So the slope of the first segment of his run, the first 10 minutes of his run, his average rate of change or speed would be 1 over 20. So it says determine the rate for the 40 minutes while he is running. So we're going to use the starting point here. So it'd be 10 and 0.5. And we're going to use 50 and 5.5. So that would be the points that we use for the slope formula or the average rate of change formula. And when you do that, you can see 5.5 minus 0.5 is 5, and then 50 minus 10 is 40. 5 over 40 divides to 1/8, and that is his average rate of change for his running part. So this is for the jogging, and this is for the running part. So it says choose the words to complete the sentence. The units for these rates of change are miles per minute. So if you look up here, time in minutes, distance per mile. So that comes directly from the graph. All right, so it says, how were the values used in the second calculation determined? The values were taken from 2 points on the graph. x1, y1 equals, so x1, y1, that was the 10 and the 0.5. And the x2, y2 was the 50, and go over. And since these are going by 0.5s, that is 5.5 right here. So you're just looking at the graph to find those points. So it says choose the number to complete this sentence. His rate of change while running is, all right, so his rate of change while running is 1/8, and while jogging is 1/20. So if we look at how these compare, we can see that it's going to be 2.5 times his rate of change while jogging. And if you go 1/8, if you double that, it's 2/16, and then 2/16 is twice this, and then another half would be the 4 left over. So you got 2.5 times his rate of change while jogging. And all they did was divide those and reduce the fraction to show that here. If you can't just look at that in your head, and a lot of people can't do that. So this is mathematically, and remember, a fraction divided by a fraction is really a fraction multiplied by the reciprocal of this fraction. So that's why you get the 20/8. And then 8 goes into 20 2 times evenly, and 4/8 left over is the 0.5 or the 1/2. All right, now determine the average rate of change for his entire workout. All right, so for the entire workout, would use the first point on the graph and the last point on the graph. So if you want to find the average rate of change for his whole workout, you're going to use 0, 0. And the 50 and the 5.5. So that's why they chose these 2 points here. And that average rate of change would be 11 over 100. So his average rate of change for his entire workout is 11 over 100 or 0.11 miles per minute. How does Tracy's average rate of change compare to his jogging and running rates? Explain why this makes sense for the real-world situation. All right, so how does his average rate of change compare to his jogging and running? Well, his average rate of change for the whole workout will be somewhere in between his jogging rate and his running rate. And that should make sense that that average falls in between these two numbers here. So hopefully that does make sense. Let's see what it says for real world situation here. All right, so it says it will be somewhere between the two rates. It makes sense for the overall rate of change to be between the faster and slower slip rates, but closer to the faster rate since he spent more time running at the faster rate than he spent jogging at the slower rate. All right, so that gives it to you kind of in more detail. Since he spent 40 minutes running and only 10 minutes warming up, that average rate of change will be in between those, but it will be closer to his running rate. All right, I believe that is all for task 5. If you have any questions, let me know.